Hi, grade 12. Our study today is about integral. What is an integral? Before we took the derivatives, now we're going to talk about the opposite of the derivative. It's called antiderivative. Before we used to have f of x, and if we derive it, we're going to get f prime of x. This is the derivative. Now I want to find a function before f of x. What function I may get, this is the name by big F of x, always by capital of the variable. If you have small g, big G. What function, if I derive it, if I do the derivative, I will get f of x. Before I used to go from here till here, now I want from a function to get, if I derive it, to get f of x. This is called a primitive or antiderivative. If big F of x is a primitive of f of x, certainly f of x plus c is also a primitive. Why? If this big F of x is primitive, so if I derive it, what do I get? As we said here, small f of x. Now, if you add to it plus any constant also, if you derive it, you're going to get small f of x. So how many primitive we have for a function? We have infinitely many because we have a plus c. The sum of all of these primitive, this is denoted like it's called integral. The sum of all antiderivative, it's called the integral of f of x dx. Okay, and integral of f of x dx equal big F of x plus c. What is the characteristic of the integral? If I take the answer of the integral here, and if I derive this one here, the answer, I get what? I get inside. Okay, because since big F of x is an antiderivative or a primitive, if I derive it, big F x prime, I will get what? F of x. This is called the primitive, and this is called the integral. Let us take some example. Before I start, I'm going to ask you, suppose you have, I'm going to ask, what function, if I derive it, I'm going to get 1? You're going to tell me all it's x. If I derive x, I get 1. So integral of 1 dx is x plus c. Why? Because derivative of the answer here is 1. What function, if I derive it, I'm going to get 2x. You're going to tell me all it's x squared. So integral of 2x dx is x squared plus c. What function, if I derive it, I will get what? Sine x. So if I derive minus cosine x, I will get sine x. What function, if I derive, for example, here, I will get first of all cosine x. You're going to tell me sine x if I derive it. What function, if I derive it, I will get minus 1 over x squared, and you're going to tell me 1 over x. We're not going to move this way. We have a properties we need to memorize. These are all the properties of the integral. The main property here, other than the these are all trigonometry. If you derive the answer here, you're going to get inside. This is the main important properties. We're going to use it a lot here and in chain rule. That integral of xn is xn plus 1 over n plus 1. What does it mean? Integral of x cube, it will be x4 over 4, x4, x5 over 5, x6, x7 over 7, x10, x11 over 11. For example, x minus 2, if you add a plus 1, x minus 1 over minus 1, x power 3 over 2, it will be x power 3 over 2 plus 1 over 3 over 2 plus 1, etc. These are for exponential, and this is for logarithm. We're going to move gradually on these integral by example. Find integral of 3x cubed minus 4x minus 7. So this is of the form x power integral of xn is xn plus 1 over n plus 1. So 3x cubed, you add a power to it 1. So it will be 3x4 over 4 because 3 plus 1. Here the power already is 1. You add 1, it will be x squared over 2. Here I don't have, it's minus 7x plus c. Let us do the vice versa. Why this is true? Because if you multiply, if you do the derivative, it will be 12x cubed over 4, 3x cubed. 8x over 2 minus 8x over 2 minus 4x. In the derivative of minus 7x is minus 7, and of constant is 0. Here, what do? We expand distributive property. You multiply all of these. If you multiply, this is the final one you're going to get. You're going to find the antiderivative. So it's the form xn plus 1 over n plus 1. So 10x4 over 4 minus 9x cubed over 3 plus 4x squared over 2, which is 2x squared, plus 3x plus c. More problem. Here, I have it down, I take it up, it will be 3x minus 2. Here, like we did in derivatives, we're going to do in integral. This will be 2 over 5, this will be minus 1 over 4, etc. The same formula. So what derivative of what function will give you 2? It's 2x. Here you add plus 1. In integral, we used to put minus. No, here we add. So minus 1 over minus 1, 2 over 5 plus 1, it's 7 over 5. You divide it by 7 over 5, or you multiply by 5 over 7, the inverse. You're going to see later I'm multiplying by the inverse here. Minus 7 over 2, if you add the plus 1, 3 over 4 divided by 3 over 4. Minus 2x squared over 2 minus x squared. Integral of minus 1 minus x plus c. So here, sorry, you have 2x. Now, just simplification, you take this down and you minus times minus plus, so 3 up 3 over x. Here times 5 over 7. 5 over 7, here you have this one, times the inverse, 5 over 7, so it will be 25 over 7, x 7 over 5. So here, if you multiply by 4 over 3, you're going to get 14, because 4 and 2 cancel, 14 over 3, x 3 over 4, etc. Come in here, the same story, it's of the form xn, so 2x power half, 3x cubed, power minus 3 up, sorry, and 5 over 3 x power minus 2 over 3. If you add plus 1 to each one, so it will be half plus 1, 3 over 2, divided by 3 over 2, or multiplied by the inverse. Here plus 1, it will be minus 2 over minus 2. Here plus 1, it will be 1 over 3, divided by 1 over 3, or multiplied by the inverse, 3 over 1. So 4 over 3, x power 3 over 2. Here 3 over 2, by the way, it's not 2 over 3. So corrected, please, here 3 over 2. Minus and minus, it's a plus, 3 over 2. Because I have x power minus 2, I take it up. 3 and 3 cancel out, so 5x power 1 over 3 plus c. If I go more, same as before. This is x power half. X power half, you add plus 1, x 3 over 2 times 2 over 3. 2x squared over 2, because this is 1, and minus 1, it's minus x. Here I split the division because I don't have a formula for that one. 2 radical x over x. Radical x is x power half, minus 3x over x, minus 3 over x. You take the power 1 up, it will be half minus 1 here. If you do it, what do you get? Minus half. X and x cancel, and 3 over x. Now, this one you add the plus 1, it will be 2x power half over half, which is 4x half. Integral of minus 3 is minus 3x, and you took up integral of dx over x is ln x. Sorry, dx over x is ln x. So that's why if you want to find this integral, it's of the form 1 over x, so minus 3 ln x in absolute value by the formula. You can check it up. Here you have this one. I'm going to put the integral. I have cosecant square. This is the formula of cosecant square. I have cosine. This is the formula of cosine. Exponential. This is the formula exponential. It's written up. Let me start by the first one. If you have cosecant square kx, it will be, you have first of all the 2, you put it up. It will be cotangent 2x kx 2x. You divide it by k. The derivative of 2x is what? 2. You divide here by 2. For this one, cosine is sine. I have minus 3 outside. Sine 5x. And derivative of 5x is 5. You divide it by 5. So you divide it by 5. The k, when you divide it, it means you divide by the derivative of inside. Exponential, you write it as it is, as we said, ekx. 7e minus x. Derivative of minus x is minus 1. So if you divide by minus 1, minus and minus, it will be plus. Here, these are the formula. This is exponential of base a. Here, exponential. Here, cosecant, cotangent. Let me start by the first one. So it is 5, as we said. 3x, akx remains as it is, 3x. K is 1, so 1 here I have, no need to put it. And because I have 3 power x, in derivative we used to multiply by ln 3. Here we divide by ln 3. Here the same thing, 2 power 3x remains as it is, divided by the derivative, which is 3, and we add to it ln of the base ln 2. This is cosecant cotangent. It is minus cosecant, but I have minus, it will be plus cosecant 3x, and derivative of 3x is 3, so I divide it by 3 like here, okay? Sine, this is the formula of sine. Exponential, this is formula of exponential. Logarithm, this is the formula of logarithm. So this sine, it will be minus 2 cosine 5x, derivative 5 divided by 5. As we said, in derivative we used to multiply, here we divide. 3ax is the 3ax, nothing to change. Here minus 7a minus 2x, derivative of minus 2x is minus 2, so I divide by minus 2, minus and minus, it will be plus. 1 over x, it means 5, like this one, ln x plus c. Now here, this is the formula of sine, integral, secant tangent, this is secant tangent, and secant square. Let us start. Sine is minus cosine 5x, minus 2 cosine 5x, derivative of 5x I divided by 5. Secant tangent is just the formula, secant x, but I have a 3 before, so minus 3. Here I have secant square. Secant square is tangent, so I put tangent 7x as it is. I have 2 before, I put it here. Derivative of 7x, it means over 7. Here, this is the formula of tangent square. So it is, first of all, as it is, I write it up, 3 tangent 5x, I divide it by the derivative, which is 5, and I add to it minus x plus c in the property. The last 3 examples. So like the derivative, we're doing the properties. This is the properties of cotangent square. So first of all, I have cotangent square, I have the 2, I put it up, I put minus. If I have cotangent square, the answer is cotangent kx, so I write it as it is, cotangent 3x, but the derivative of 3x is 3, so I divide it by 3. I add to it minus x, so here I forgot to put minus x, and then I have minus 2x, so it will be, the sum is minus 3s for these two, be careful. This one, this is the formula of sine square. So I put, I have 2 and I have half, so it will be 2 over 2. X is x, minus is minus. So I put sine of double of angle. I have 2kx, kx to kx, so it will be 8x. Derivative of ax is over 8. I have also then the minus 2 is alone. Derivative integral of minus 2 is minus 2x plus c. And the last one, this is the formula of cosine square for the first part. Here, the sign, you know the sign. Integral of sine is minus cosine, so minus 2 cosine x. Remains for the first one. So I put the half. I have the 3 over 2. X is x plus sine double of the angle, sine 10x, and double and derivative of 10x is 10. So this is the basic derivatives. I hope I will see you tomorrow in class. Hope that you understood all the basic derivatives. It's very easy. It's like the basic integral, sorry. It's like the derivatives. Sometimes when you have, instead of multiplying, for example, by the constant, for example, in cosine kx, you divide. So you need to memorize, as I said, these properties. You need to know them by heart. And if you have a test of integral, I advise you to write them on your scratch so that not to do any mistake. See you tomorrow.